So in this video, we are going to start with our new chapter, chapter number 1, which is called number systems. So the first section in this chapter 1.1 is nothing but a quick revision of the following four numbers. So we have already known these numbers and we have seen them in our previous standard, in 8th standard, but we are just going to quickly revise these four numbers. The first one is natural numbers, second one is whole numbers, then the third one is integers, and the fourth one is rational numbers. So let me zoom in here and try to focus on these four numbers. So first of all, we are quickly going to start by drawing a number line for these four numbers. Okay, so let me draw a line here. And what is the number line, or what are the numbers that are included in natural numbers? We will represent it through a number line. So let me like zoom in. Okay, so as we all know, natural numbers, they are start from 1. So we have 1 here, then we have 2, then we have 3, and then dot dot dot, and then there is this arrow. Now this arrow is very important. This arrow indicates that there are infinite numbers on the right hand side of the number line. Okay, that is a very important point not to be forgotten when representing natural numbers on a number line. So this is how you represent natural numbers on number line. Very simple, very straightforward. Next, we have whole numbers. So even for whole numbers, we have, let me draw the line. We have similar concept. We have a line with right hand side being infinite, and the only difference is that we start from 0. Instead of starting from 1, we start from 0, and rest all numbers are same. They're same as what we had in natural numbers, 1, 2, 3, and so on. So once again, whole numbers is nothing but all the natural numbers plus 0. 0 is included in that. Now next we have integers. Now for integers there is a little bit of difference. Okay, so I'm going to zoom out a bit because I'm going to need more space. We have this arrow on both the sides of the line. Okay, which means the numbers extend infinitely on left hand side as well as on the right hand side. Okay, so in the center we have 0. So this is my 0, and then on the right hand side we have our positive numbers 1, 2, 3, and so on. And on the left hand side I have negative numbers -1, -2, -3, and so on. Okay, so note our integers is a much bigger set of numbers. Our integers is much bigger set of numbers than natural numbers and whole numbers. It includes all, if you see the numbers from 0 to right hand side, these are all the numbers that are existing in the whole numbers. So it includes all these numbers, plus it also includes all the negative numbers -1, -2, -3, and so on. Okay, so that's an important difference in integers. We have added all the negative numbers, and it extends infinitely to both the sides, to the left hand side as well as to the right hand side of the number line. And now finally, last but not the least, is rational numbers. So for rational numbers, we don't have any representation on the number line, but we define rational numbers as a number which can be expressed in the form of p by q. Okay, in the form of p by q, where p is any integer. Okay, where p is any integer. So we know what are integers. We just define these integers. This is a number line, or this is a set of integers. So p can be any integer, and then q also can be any integer except 0. So we don't allow 0 to come to the denominator. What is the reason for that? Because in mathematics, division by 0 is never defined. It does not exist. We never ever ever divide any number by 0. That is not allowed. It is against the rules. So when we express rational numbers in the form of p by q, the denominator can be any integer from this number line except this fellow, except 0. And p can be an integer. P can be 0, -1, 1, 2, 3, anything. So this is how we have quickly revised what are natural numbers, whole numbers, integers, and rational numbers. Now this is the representation in the form of number line. Now one important point about these four set of numbers is their symbol. So there is a symbol to represent each of them, and I'm just going to make a note of it. Okay, let me get a straight line. So I'm going to just make a note of it. The four symbols for these four set of numbers. So natural numbers are represented as n. So I'm going to write n here for natural numbers. Whole numbers are represented as w. So that's w. Integers are represented as z, and rational numbers are represented as q. So again, there is no logic behind this, or there is no like a concept behind this. It's just for the sake of convenience we use n, w, z and q to represent this whole set of natural numbers. Because in mathematics, whenever you want to represent something, instead of saying that this is my natural number, so you have to use this number line to represent a natural number or whole number or integers. Instead of that, what we are going to use is these symbols. We are just going to say n, which will be understood that, oh, n stands for set of natural numbers. N stands for this whole set of natural numbers. W stands for this whole set of whole numbers. Similarly, Z and similarly Q. So this is a symbolic representation. So this is the symbolic representation of our uh, four set of numbers, and this is the number line representation of these four set of numbers. Now, there's one interesting thing about rational numbers which we are going to focus on. Let me bring it down here. Okay, so let's consider one natural number. So this is the point of focus for this discussion. Now let's consider one natural number. Let's say 5 by 7. Okay, very clearly 5 by 7 is a rational number because it is of the form p by q. Okay, just to bring this into the focus, this is the definition of rational number. It is of the form p by q. P is any integer, 7 is, q is also any integer which is other than 0. Now for this rational number, let me bring it into focus. Yes, now this rational number 5 by 7, what I'm going to do is I'm going to represent it into a different form. Okay, sorry, I'm going to represent it in a different form called as 50 by 70. Okay, now what I have done here, I have multiplied by 10 both the numerator as well the denominator. I have multiplied by 10 and I have got 50 by 70. 50 by 70 is equal to 5 by 7. Now I will continue this operation of multiplying the numerator and denominator by some value and try to get different numbers. So I'm going to make this again. Let's say I'll take 50 into 70, and let's say I will multiply both the numerator and denominator by 3. Okay, in that case what I get is 150 upon 210. Okay, now again 150 divided by 210 is equal to 50 by 70, and that is also equal to 5 by 7. And I can continue this on and on. I can multiply 150 divided by 210 by, let's say, minus 2. I'll multiply both numerator and denominator by minus 2. So what I'm going to get is minus 300 divided by minus 420. So note, look at this all the representations of one fraction or one rational number 5 by 7. So 5 by 7 is same as 50 by 70, is same as 150 by 210, is same as minus 300 by minus 420 by multiplying the numerator and denominator by some integer. Thus, we conclude that rational numbers do not have unique representation. This is the important point about rational numbers which I wanted to bring about. So I have noted it down here. Yes. Note, rational numbers do not have unique representation in the form p by q. So when it comes to this form p by q, there is no unique representation. They can be represented in all these different forms, and all of these different forms are equal to each other. This is not the case with respect to natural numbers, whole numbers or integers. They have a very unique representation. So minus 1 can be represented as minus 1 itself. There is no other representation. 2 can be represented as 2. Okay, 0 is represented as 0. There is no different forms in which 0 can be represented. However, rational numbers have this unique property that they do not have, okay, let me underline this important point, they do not have unique representation. So that's an important point about rational numbers. Now let's go ahead and try to solve some examples based on these concepts. Okay, before we move on to solve the examples, one important point or one important term rather that I have missed to tell you is these all different forms of rational numbers, okay, they are called as equivalent, okay, equivalent rational numbers. Okay, all these different forms of rational numbers are called as equivalent rational numbers because they're equal to each other. They have the same value and they have the same concept. Okay, so now let's finally move on to our examples. We're going to see example number 1 first. So let's see what that example is. Yes. Are the following statements true or false? So we'll read statements one by one and we'll decide whether they're true or false. Statement number 1. Every whole number is a natural number. Every whole number is a natural number. Now, in order to understand, in order to make decisions about these statements, whether they're true or false, I think we're going to need these number lines. Okay, these number lines will help us to decide whether these statements are true or false. So what I'm going to do is I'm going to just copy them. Okay. 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 Copy. Okay. I'm just going to paste them here. Paste. Yes. So these are the different number lines we have for each of our statements. Okay. Now we are going to decide whether the statements are true or false. The first one, every whole number is a natural number. So this is a list of whole numbers. Okay. We didn't take the, so this is the list of my whole numbers. This is the list of my natural numbers. Now this statement reads that every whole number is a natural number. So consider this whole number 0. Is it present in the natural number? No. So every whole number cannot be a natural number. These from 1 onwards, all whole numbers are natural numbers, but this cannot be a natural number, and hence I'm going to mark this as a false. This statement is false. Now next, statement number 2. Every integer is a rational number. Okay, so once again, this is my integer. These are my integers, and these are my rational numbers. Okay, now every integer, so every integer is a rational number, is a rational number. This statement is true because we have seen that every integer can be represented in the form of p by q, where q will be 1. Okay, so for example, take any integer, let's say 0. 0 can be written as 0 by 1, and 0 by 1 is of the form p by q. Thus 0 is a rational number. Similarly, you take any integer. If I take -1, you just put it as -1 by 1. That becomes a rational number. Then you do 3. 3 divided by 1 is also a rational number. So you take any integer from this number line, and if you just do it divided by 1, that becomes a rational number, valid rational number representation. So every integer is a rational number is a true statement. So I'm going to mark it as true. Okay. Now let's look at the last statement. Every rational number is an integer. Every rational number is an integer that can be seen on this number line. This statement is obviously false. So consider this rational number 1 by 2. 1 by 2 is a valid rational number? Yes. Can you represent 1 by 2 on this number line? On this integers number line? No. So every rational number is an integer? No. False. Few rational numbers are integers, but not every rational number. So I'm going to mark this as false. So thus we have seen these three statements and mark them true or false based on these definitions or these concepts of number lines. Now let's go below. We have another example, example number 2 to be solved. Now what does example number 2 ask? Let's read it out. Find 5 rational numbers between 1 and 2. Okay, so we have two numbers 1 and 2, and we have to find 5 rational numbers between them, between 1 and 2. Now this is the first thing we have to do is we have to represent 1 in the form of rational number, so that's going to be 1 by 1. Then we'll represent 2 in the form of rational number, which is 2 by 1. Okay, take a pause and confirm that this is a valid representation of a rational number. It is of the form p by q. Okay, now we have to find 5 rational numbers between 1 and 2. So now what I'm going to do is I'm going to represent them I'm going to multiply both numerator and denominator by 10. So this is going to be 10 by 10. Okay, and I'm going to do the same thing to this. So this is going to be 20 by 10. Okay, this is an equivalent rational number. We are using the concept of this, the concept that we discussed above, equivalent rational numbers, where we multiply numerator and denominator by some integer and they are the same, they are equivalent. So thus 10 by 10 and 20 by 20 is the equivalent representation of 2 by 1 and 1 by 1. Now between 10 by 10 and 20 by 10 there are several rational numbers. Okay, let me list them down. We have 11 by 10, we have 12 by 10, we have 13 by 10, we have 18 by 10, we have 19 by 10, and finally we have 20 by 10. So from this set of rational numbers, you can pick out any 5 that you want, and that will be the answer for this question.